Hi, this is Somshakar from Maths Guru Academy. If you are watching the video for the first time, please subscribe to my channel and press the bell icon to get the notifications of my latest videos. So in today's class, we will solve exercise 1.2 of the first chapter, real numbers. So in that first one, prove that root 5 is irrational. So we have to prove that root 5 is irrational. As usual, we first will consider root 5 is rational, then we will prove it is irrational. So let us assume root 5 is rational. Then root 5 can be written in the form of a by b. So we have one condition that a and b must be co-primes or co-primes, and one more condition that b must not be equal to 0. Next we will shift b to the LHS. What it will becomes root 5 into b is equal to a. In the next step we will do the squaring on both sides. So squaring on both sides. So what it will become, root 5 into b whole square is equal to a square. So root 5b whole square means this square is for both root 5 and b. So what it will becomes, root 5 into b whole square. So if we simplify this one, this square is for both root 5 and b. So root 5 whole square into b square. So here square and square root cancel, remaining 5, and this b square as it is. So 5b whole square can be written as 5b square is equal to a square. So from this equation we came to know that 5 is one of the factor of a square. That means this a square can be divided by 5, right? So therefore 5 divides a square, so as well as 5 divides a. So this is from theorem 1.2. so let it be equation 1. So if a is divided by 5, then we will get some integer, right? If we multiply that integer with 5, we will get a. For example, so let us consider this value of a is 30, right? So if 5 divides a means this 30 can be divided by 5, right? 5 ones are 5, 6 are 30. That means if we multiply that 6 with 5, we'll get 30. That means the value of a, right? So likewise, if a is any number, then that number can be divided by 5, then we will get some integer. So that means if we multiply that integer with 5, we will get a. So let a is equal to 5k. So if we multiply 5 with some integer, we will get the value of k, right? Where k is some integer. So this will be equation 2. Substitute equation 2 in equation 1. So what it will becomes, so here 5b square as it is, in the equation 1 5b square as it is, in place of a we will write 5k, so square as it is. So 5b square, 5k whole square, if we simplify this one, 5 square 25, k square as it is. Next we will shift 5 to the RHS, it will become 25 k square by 5, 5 ones are 5 5s are. So b square is equal to 5k square. That means from this equation we came to know that 5 is also a factor of b square, right? So therefore if 5 is a factor of b square, then this b square can be divided by 5, right? Therefore 5 divides b square. That implies 5 also divides b. So again from theorem 1.2. So let it be equation 3. So from equation 1 and from equation 2, we came to know that 5 is a common factor of a square in the equation 1, and also 5 is a factor of b square in equation 3. So from both the equation, 5 is a common factor for both a and b, right? So from equation 1 and 3, 5 divides A and B. That implies A and B have common factor 5, which is contradiction to our assumption that, what is our assumption? That A by B are co-primes, right? So assumption that A and B are co-primes. So therefore root 5 is irrational. Next question, prove that 3 plus 2 root 5 is rational. As usual, first we will consider this 3 plus 2 root 5 is rational, then we will prove it is irrational. Let us assume on contrary 3 plus 2 root 5 is rational. Rational means this 3 plus 2 root 5 can be written in the form of A by B, right? Where this A and B are co-primes. And one more condition, this B is not equal to 0. So keep root 5 as it is and shift this 3 and 2 to the RHS. So first we will shift 3 to the RHS. What will it become? 2 root 5 is equal to A by B. So plus 3, if it goes to the RHS, it will become minus 3, right? So 2 root 5 is equal to, so we will take LCM here. So in the denominator nothing is there, means 1. So for 1 and B, the LCM is B. So here into B into B. B and B cancels. So A into 1, A minus. So 3 into B, 3B. So next we will shift 2 to the RHS. It will goes to the denominator. So root 5 is equal to A minus 3B by 2B. So it is in the form of fraction, right? It is in the form of A by B. That means A minus 3B by 2B is rational, right? If this is considered as rational, then LHS should be also rational. That means root 5 is rational. But we know that root 5 is irrational. So we know that root 5 is irrational, which is contradiction to our assumption. What is our assumption? 3 plus 2 root 5 is rational, right? Therefore 3 plus 2 root 5 is irrational. So keep root 5 as it is and shift everything to the RHS. So next question, question number 3. Prove that the following are irrationals. In that first sub question, 1 by root 2. We have to prove that 1 by root 2 is irrational. So as it is, first we will consider this 1 by root 2 as rational. So let us assume 1 by root 2 is rational. So if 1 by root 2 is rational, then this can be written in the form of A by B. 1 by root 2 is equal to A by B, where A and B are co-primes and B must not be equal to 0. So we have to keep root 2 as it is, right? So but root 2 is in the denominator. So if we reciprocate this one, what it will becomes? Root 2 is equal to B by A, right? So it is in the form of fraction. That means we can consider RHS as rational. Therefore B by A is rational. If this is rational, RHS is rational, then LHS should be also rational. Therefore root 2, that implies root 2 is rational. But we know that root 2 is irrational, right? But we know that root 2 is irrational, which is contradiction to our assumption that, what is our assumption? 1 by root 2 is rational. So what we took 1 by root 2 is rational, that is wrong. Therefore 1 by root 2 is irrational. So next one, we have to prove that 7 root 5 is irrational. So as usual, first we will consider 7 root 5 as rational, then we will prove 7 root 5 is irrational. Let us assume 7 root 5 is rational. So that means 7 root 5 can be written in the form of a by b. So we have one condition that a and b are co-primes, and this b must not be equal to 0, right? So keep root 5 as it is and shift 7 to the RHS. What it will become? Root 5 is equal to a divided by 7b, right? 7 goes to the denominator, then it will become a by 7b. So it is in the form of a fraction, right? Nothing but a by b form. Then this can be considered as rational. Therefore a by 7b is rational. If RHS is rational, then LHS should be also rational. So that implies root 5 is rational. But we know that root 5 is irrational, right? But we know that root 5 is irrational, which is contradiction to our assumption. What is our assumption? 7 root 5 is rational. So what we have took 7 root 5 is rational, that is wrong. Therefore 7 root 5 is irrational. So next we have to prove that 6 root 2 is irrational. So first we will assume 6 root 2 is rational, then we will prove it is irrational. So let us assume 6 plus root 2 is rational, right? If this is rational, then 6 plus root 2 can be written in the form of a by b. So we have a condition that a and b are co-primes. Co-primes means it should have common factor 1, and b must not be equal to 0. So keep root 2 as it is and shift 6 to the RHS. What it will become? Root 2 is equal to a by b plus 6. It will become minus 6. So we have to take the LCM here. For 1 and b, LCM is b itself. So root 2 is equal to, b is LCM, so here into b. So b and b cancels. So a into 1 a minus here 6 into b 6b, right? So this is in the form of fraction, right? Then it is considered as rational. Therefore a minus 6b by b is rational. If RHS is rational, then LHS should be also rational. That means root 2 is rational. But we know that root 2 is irrational, right? We know that root 2 is irrational, which is contradiction to our assumption that 6 plus root 2 is rational. That means what we considered 6 plus root 2 is rational, that is wrong. Therefore 6 plus root 2 is irrational. Hence proved. Thank you.